Hi, this is Mrs. James. It's March 4th, it's Tuesday, and today we're going to go through several papers that you have and get a few new papers. First thing, we'd like to go over the quiz that you took last Thursday. This had the speed and acceleration problems on it. We're going to go over the second page of the lab that you did yesterday, and we're going to practice interpreting graphs some more. Let's start with the quiz. The quizzes are on the big desk. The substitute is going to ask for some volunteers to help pass them out and pause the tape while those get passed out. When you're ready to go, hit play again. Alright, our first question is about a cow walking across a field towards a barn. So I'm going to go through the steps, read along on your paper. If you did something wrong, you should correct it so you can study your quiz. Alright, first I mark the numbers. I see here a meters per second squared. And here I see meters per second and meters per second. So what do I know? I know acceleration, I know my initial and my final velocity. The initial velocity is 2.5 because it went from. The final is 4.50 meters per second. It went to that. Trying to find time. There's my equation. I rearrange it by multiplying both sides times t. The t's cancel, and I'm left with time multiplied by acceleration gives me delta v. Divide both sides by a, and I get my final equation. Time is delta v over a. I plug in my numbers. 4.5 minus 2.5 meters per second divided by 1.7. Everything cancels except for the second. One of the seconds down here is a denominator of a denominator, so it becomes a numerator. 1.2 seconds. Next problem. How far can you get if you walk 2.3 kilometers per hour for 7.23 hours? I underline the important numbers here. I have kilometers per hour and hours, so I know kilometers per hour is speed. My time is my 7.23 hours. I'm trying to find distance. Here I rearrange my equation for time. So first I have to bring time up to the numerator. Multiply both sides times time. And then I have we're solving for distance. So multiply both sides times time. Times speed equals distance. Alright, now all I have to do is plug in. I plug in my speed. I plug in my time. Hours cancel. I'm left with my answer in kilometers. It has 6 significant figures. Why? Well, if you go back, this number has 6, and this one has 6. So my answer should also have 6. So I have to add a 0 to make it more precise. Next one. What's the speed of an object that goes 405 meters in 0.250 hours? Highlighted something pretty important here. We want the speed in meters per second, but the time is given in hours. So I'm going to have to change the hours to seconds. I do that with dimensional analysis. So what do I know? I know my distance, and here's my time. Here's my conversion factor 1, which changes it to minutes. My second conversion factor changes it towards seconds, and 0.250 hours is equal to 900 seconds. The best place to do your conversions are up here in the What Do You Know section. A lot of you did not do this. Remember, that's only a half-point deduction if you did not do the conversion. We're trying to find speed. It's distance divided by time. I plug in my numbers, my 405 meters divided by 900 seconds. I get 0.45 meters per second. I need 3 significant figures though. Why? 0.250 has 3. 405 has 3, so I write my answer with 3. My units are meters per second. Alright, a ball is rolling at 10.5 meters per second. It comes to a stop in 0.052 minutes. I want to know its acceleration. Meters per second. My time is given in minutes, so I have to convert my minutes to seconds before I can solve. And here it is right here. Minutes. Here's my conversion factor. My minutes cancel. And here's my final answer. that's going to get plugged into my equation for time. So acceleration is change in velocity over time. 0 minus 10.5 meters per second divided by my new time, 3.12 seconds, gives me a negative answer. Well, that's okay because it's slowing down. Alright, with 2 sig figs, negative 3.4 meters per second squared. Alright, the next thing we're going to do is look at your lab paper from yesterday. This is one we did the lab pros and the motion detectors with. So we're going to have you pause the video while you get those papers out. Alright, you should have those papers out now. We're going to look at the back page. Question number 1. What motions were necessary to make this graph? Well, during this one right here, we moved away from our reference object, whatever that was, maybe the motion detector. B, we moved away at a faster speed. And C, we moved away at an even faster speed. Do you notice that my instructions for each step gave both the relative speed and the direction the object was moving? Alright, how about this one? For line segment A, we move backwards, or you could have said move towards the motion detector at a fast speed. Why do we know it's fast? Well, because it's a pretty steep slope. We stood still, and then we moved away. This time it was at a slower speed. Alright, let's look at the next page. Pause if you need to at any point in time on this one, so you can write those down. Alright, now we're going to draw a graph to demonstrate this motion. We want the person to, don't want to do that, sorry. We want the person to walk slowly away from the detector, then quickly away from the detector, and then very slowly back towards it. So let's go. Slowly away from the detector. There you go. Slowly away. Quickly away from the detector. Alright, so going the same direction, but we have a steeper slope. And very slowly back towards the detector. Next one. Last one on the page. Draw a graph to demonstrate this motion, and again, pause if you need to so people can check their answers. The person stood still. Here we see standing still. Walked away from the detector. Now, it doesn't say what speed it is, so I just picked one randomly. And then stood still again. So there's our graph for that one. Alright, now we've got one more worksheet for you to work on. It's also on graph interpretation, so just some more practice for you. So you're going to pause while the sub has some volunteers pass out the paper. And then once they're passed out, we're going to turn this back on and I'm going to give some instructions. Alright, the paper should be passed out now. So here's the instructions. You are going to match up each of the graphs with the description that goes with it. Here's the very first one done for you. Alright, this is picture A, and number 5 is the right description. Tom left his home for a run, but he was unfit and gradually came to a stop. Now, the word here, gradually, is important. A lot of the graphs that we've looked at have had lines that change really drastically as the slope changes. And it's only the idea that Tom changed his speed gradually that allows this to be a curve. Alright, again, we haven't seen those yet in class, but he changed his speed so quickly that we can't see the separate little lines and we get the curve instead. I think it's the only one in today's activity that has a curve. Now B, I've also done for you. B, we don't have a description for, so it's number 10, make up your own story. Now, I don't need for you to do that right now. You can make up your own story later on. We'll have time for that set aside at the end of the class. Alright, so what I want you to do now is, working by yourself, I want you to try to match up all the other pictures with the stories that go with them. Alright, so we're going to have to pause the tape while those happen, and then we're going to go over the answers. I'd like you working by yourself for this for a set amount of time. So your substitute's going to watch you. When he thinks that you've done all that you can, he's going to let you check your answers with each other, but not until he says so. So starting out, working by yourself. When you have checked it by yourself, and then when you have checked it with somebody sitting near you, then you will be able to unpause this and continue. Alright, you should have had time now to look at the all the different pictures and match them to the right answers. And let's see, C is 4. Tom walks slowly along the road. Here he is walking slowly. He stopped to look at his watch, realized he was late, and then he started to run. D. Opposite Tom's house is a hill. Tom climbed up the hill slowly. He walked across the top, and then he ran quickly down the other side. He's still going away though, so the line is still having a positive slope. Now we're going to go more quickly through the others. Pause if you need to on any of them. E is number 6. F. Oh yeah, I guess there are some curves in this one. We also have gradually, so you see the gradually in the curves. So F is number 3. G is number 1. H is number 8. So how can he be in 2 places at one time? So that's right here. This is showing Tom at 2 different distances. This distance right here, and this distance right here at the same point in time, and that's not possible. I is number 7. J is number 9. Alright, now again, if you need to go back and look at any of those, you can rewind the tape a little bit. We're going to have another pause soon. Depending on how much time you have left in the class, what I'd like you to do is I'd like you to work in small groups to come up with a story that would match this particular graph. Alright, you're going to work in groups of 2 or 3. You're going to make up a little story similar to the ones that you just read, and then you're going to write that down, and then the substitute will have you share those with the class. So be thinking a lot about the slopes that you see, about the direction the object's moving as it goes through this time period, and then this time period. Alright? And then you'll share this with the class. If you have extra time after this, what I would like you to do is, I would like you to have a volunteer to go to the board and tell a story, and then someone else to go to the board with them and draw the graph that goes with it. Alright? So that would be what you would do to fill up any remaining time. You can either do that on the blackboard, or if you can get Smart Notebook open, you can do that in the Smart Notebook file. Alright, tomorrow, remember, there will be Chromebooks in the room. You are going to go to Moodle, and when you get into Moodle, remember, you don't have to sign into the Chromebooks. You will have to sign into Moodle. Scroll down until you get to the motion section, and you are going to do this activity right here. Review for the chapter test. That's the activity that you're doing. Alright? You only have a 20-minute class, most of you, because of the scheduled late start. If you don't get finished, finish it at home. The substitute has a list of all your grades. He knows that some of you will get done quicker than others. For instance, if you have an A in my class, you might get done pretty quickly. If you don't have a good grade in my class, it will take you much longer, and he will hold you accountable for that. If you are absent tomorrow, do the review at home so that you can still take the test on Thursday. Alright, I will see you on Friday. So remember, review tomorrow and test on Friday.